Okay guys, let's look at section 8.2 and we'll be graphing now the function of f of x equals ax squared plus c being some constant that we would add or subtract to our parent function. And remember, our parent function is f of x equals x squared. And in the last section we looked at f of x equals ax squared, and if it was positive and we had an a value greater than 1, then we had vertical stretch, and if we had a value between 0 and 1, then we had vertical shrink. But if it was positive, it opened upwards, and vice versa. If it were negative, then it opened downwards. Well, we're going to expand on that knowledge now, and we're going to start graphing now f of x equals ax squared plus c. Okay, let me just begin with the two definitions. If c is greater than 0, then the graph is a vertical translation or shift c units up. So in other words, the graph will be shifted upwards by as many units as c is. Conversely, if c is less than 0, then the graph is a vertical translation, the absolute value of c units downward. Okay, so those are basically the definitions. Now, one thing to keep in mind is that our axis of symmetry here is still going to remain the same with all of these functions. And that axis of symmetry, AOS for short, is x equal to 0, or the y-axis here. Okay. So even with these f of x equals ax squared plus c graphs, they'll also still be symmetrical about this y-axis or this line x equal to 0. They'll just be shifted upwards or downwards. And remember, this shape is called a parabola. Okay, so with those definitions, I'm going to go ahead and erase, and let's go ahead and look at a problem here. Okay, so c greater than 0, shifted upwards by that unit. C less than 0, shifted downwards by that same amount. And we're still going to keep our same axis of symmetry, the y-axis, or x equal to 0. So let's begin. And let's do maybe one. F of x equals x squared minus 2. Okay, well, let's go ahead and make a table. And remember, with this xy tables, I've been picking these values: -2, -1, 0, 1, and 2. And that won't change. Eventually, when we add a bx term here in the middle, that will change, but for now, it won't. Okay, so f of -2, let's plug in for x. All right, -2 squared is, you got it, +4, -2, +2. F of -1. -1 squared minus 2, -1 squared, +1, minus 2, -1. F of 0, 0 squared is 0, minus 2 is minus 2. 1 squared. 1 squared is 1, minus 2 is minus 1. And f of 2, 2 squared minus 2, 2 squared is 4, 4 minus 2 is 2. Okay, let's go ahead and plot those locations. All right, at -2, I'm at +2. At -1, I'm at -1. Let me go ahead and give us a value of -1, -2, -3. Okay, -1, I'm at -1. And at 0, I'm at -2. 1, I'm at -1. And 2, I'm at 2. Okay, and then I'm going to go ahead and draw my shape. Remember, it's a U shape, not a V shape. Okay, so if we look at our parent function, f of x equal to x squared in the darker purple, well, then we can compare it to what happened to now our function f of x equals x squared minus 2 in the lighter purple. So in the lighter purple, we had what's called a vertical shift down 2 units. So I basically took my whole function, f of x equals x squared, and I shifted it down 2 units. Okay, and then I made an xy table, picking my same 5 values, -2, -1, 0, 1, and 2, plugged in for x and solved for y. And I got this shape. So basically it takes the same shape as f of x equals x squared, except it's shifted how? Down 2. Okay, let's look at another example. And I'm going to go ahead and erase. Okay, so again, we're going to make an xy table. We're going to pick the same 5 points on either side of our y-axis. And notice our graph here also has that same axis of symmetry of x equal to 0 here, which is the y-axis, okay, which I have dotted in red on there. Okay, and I can go ahead and leave this one up. All right, let's look at our next one. F of x equals 4x squared plus 1. Okay. So on this one we have a couple things going on. Well, let's look at what we're talking about today with it, which is that vertical shift up or down. So in this case, this would be a vertical shift up 1. But we also have this value here, which remember we said was vertical stretch or shrink. In this case, it's vertical stretch. You got it, because our a value is greater than 1. So it's vertical stretch by a factor of 4 and up 1. Okay, but the process still remains the same. We make the xy table. X, y, -2, -1, 0, 1, and 2 are same 5 values. And I'm going to do here f of -2. Well, that would be 4 times -2 squared plus 1. So notice I plugged in for every x in the function. Now, do I want to multiply first, or do I want to evaluate the exponent? Well, the exponent. -2 squared, 4. 4 times 4, 16. And then 16 plus 1, 17. Okay. So notice all my PEMDAS rules still apply. Let's do f of -1. Well, that would be 4 times -1 squared plus 1. Notice I'm plugging -1 in for every x in the function. Okay, exponents first, -1 squared 1. Then I'm going to multiply second, 4 times 1, 4, plus 1, 5. And let's do f of 0. 4 times 0 squared plus 1. 0 squared is 0, multiplied by 4 is 0, and then plus 1 is 1. And if I evaluate my other points, I'd have 5 here and 17 here. And just for the sake of time, I'm just going to fill those in. Okay, let me erase. So again, same 5 points, plugged into my table and evaluated. And then I'm going to plot those points, and we're going to talk about what this graph looks like and why. Okay, so let's plot those points. -2, I'm way up here at 17. I'm just going to barely put that on the map. And that's not even realistic. It's way well above that. -1, I'm at 5. And in fact, I'm going to put that point. It's really off the map, so I'm kind of not going to look at it. I'm just going to scratch that off. Okay, 0, I'm at 1. 1, I'm at 5, and here I'm 17, which is off the map. So I'm going to try and just go ahead and draw my shape here without that other value of -2 and +2. But I know that they're way up there, and as this approaches, it's a really steep slope, and it's going to eventually hit -2, 17 and +2, 17, although they're not on my graph here. Okay, so now here's my shape of my green function, which is f of x equals 4x squared plus 1. So if I again compare this to my original parent, which is the dark purple, f of x equals x squared, well, I've got a couple things going on. Let's talk about what today's lesson's about, that up 1. So we have a vertical shift up 1. That's that plus 1 right here. And notice that corresponds to my vertex being shifted up 1. Whereas, say, on the 1 shifted down 2, my vertex was shifted down 2. So the vertex is a good place to look. And notice on both of these, they have that symmetry about x equal to 0 or the y-axis. Okay, the other thing going on with the green graph is what's called a vertical stretch by a factor of 4. And that's this 4 out front. And we kind of talked about that more in 8.1. So, well, what did vertical stretch do? It pulled it away or toward the y-axis? Well, pulled toward the y-axis. And we can see that in our graph here. It's taller and thinner. It's stretched. Okay. So that vertical stretch of 4 is what's pulling it towards the y-axis. And the plus 1 is what shifted my vertex up 1 there. And also my whole function's values up by 1 as well. Okay, so this should take care of the first part of section 8.2. And we'll continue with some other ideas in the section. Thank you.